The Hubble Space Telescope is still alive and kicking. When it first launched back in 1990, scientists expected it to have a lifespan of about 15 years. But it's the year 2022, and the telescope is still bringing us amazing pictures of the universe. That's because throughout the years, there have been 5 successful astronaut servicing missions to the Hubble, upgrading its technology and extending its lifespan. The even better news is the fact that the Space Telescope is going to continue its mission until the mid to late 2030s. Hubble just brought us an amazing view of a dense core known as CB130-3, which lies in a filament of gas and dust toward the constellation Serpens. It's in a region known as the Aquila Rift, about 650 light-years away from us, which contains numerous dark interstellar clouds. Such regions are the birthplaces of stars. Our own sun and planets were formed in similar conditions, so by studying these dense accumulations, we can learn more about our past and how we came to be. To make a dense core, we need a nebula, and the nebula needs some outside influences, such as a star passing through it or a nearby supernova explosion of a massive star, to send shockwaves through the cloud. Such turbulence deep within the nebula gives rise to clumps with sufficient mass that the gas and dust can begin to collapse under their own gravitational attraction and give rise to dense cores. As the material falls into the center, the pressure and temperature rise, and eventually a protostar forms right at the heart of the collapsing cloud that will one day become a star. In this image, at the center of the CB130-3 cloud, a sufficient amount of gas is clumped together with the right temperature and density for fusion reactions to start and the life of a future star to begin. However, the cloud is so thick that we can't see into the center. Also, you can see in this image, the density isn't constant. The outer edges of the cloud are not as dense as the center. The gas and dust here affect not only the brightness, but also the apparent color of the background stars. Central stars appear redder than the ones on the outskirts of this image. By analyzing the reddening effect, scientists can chart out the density of CB130-3, bringing us more insight into the inner structure of this stellar nursery. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.